NASA's Mars rover Perseverance has sent us the most incredible footage of Mars. With its advanced cameras and cutting-edge technology, the rover has taken high-definition 4K images that transport us to the surface of Mars like never before. As it explores the planet's ancient terrain and uncovers new insights, Perseverance offers a stunning visual journey into an alien world, continuing the legacy of its predecessor, the Curiosity rover, which gave us visuals of Mars in 4K. Both of these are pushing the boundaries of space exploration. So why is NASA spending billions for a bunch of photos? Well, they're more than visuals. To fully understand the importance of these accomplishments, we need to look at the whole thing from the very beginning. Let's get started. A new look at the Red Planet. Rovers have been instrumental in expanding our understanding of the Red Planet. Over the years, NASA has sent several groundbreaking rovers to Mars, each more advanced than the last, with missions that span over 2 decades. The first major rover, Spirit, was launched in 2003 alongside Opportunity, both tasked with searching for signs of past water. Their discoveries helped solidify the idea that Mars once harbored conditions suitable for life. In 2012, Curiosity revolutionized our understanding by landing in Gale Crater and providing high-resolution images and critical data about the planet's climate, geology, and potential habitability. Then, in 2021, Perseverance arrived, equipped with state-of-the-art technology to search for biosignatures and collect samples for future return missions. Through their lenses, these rovers have offered humanity an unprecedented glimpse of Mars, sending back stunning imagery and helping scientists visualize its diverse landscapes. Let's see how the greatest minds on our planet made all of this possible. The story of the Curiosity rover. As part of the Mars Science Laboratory mission, NASA's Curiosity rover was launched from Cape Canaveral on November 26, 2011, marking the beginning of a bold journey that would take it 560 million kilometers or 350 million miles across space to the surface of Mars. On August 6, 2012, after a thrilling entry, descent, and landing sequence, the rover touched down safely on Aeolis Paulus, a flat region in Gale Crater near the base of the towering Mount Sharp, which stands at 5.5 kilometers high. From its landing site, Curiosity began its exploration with a singular focus: to investigate the planet's climate, geology, and potential for past microbial life. Gale Crater, chosen for its diverse geological features, was considered an ideal location due to evidence suggesting that water once flowed there. The rover's exploration aims to answer a key question: could Mars have supported life, and more importantly, can it do so in the future? By examining the Martian soil and atmosphere, Curiosity aimed to detect key elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. It also sought to identify features that might indicate biological processes, such as biosignatures or biomolecules. Curiosity was also tasked with analyzing the composition of the Martian surface. This included studying the chemical, isotopic, and mineralogical makeup of rocks and soils, as well as interpreting the geological processes that have shaped Mars's surface. One of the rover's key tools, the ChemCam, used a laser to vaporize small portions of rocks and analyze the resulting plasma to identify chemical compositions, which helped map the history of water and volcanic activity on Mars. The rover also measured the present state of the Martian atmosphere, focusing on the distribution and cycling of water and carbon dioxide. These observations are pivotal for understanding the planet's climate over billions of years, providing insights into its habitability and its shift from a potentially warm and wet world to the dry, cold planet we see today. The data gathered could also aid in future efforts to terraform Mars or prepare for human exploration. Curiosity also carried instruments to study surface radiation by measuring galactic cosmic rays, solar proton events, and secondary neutrons. The rover provided crucial data for understanding the hazards posed by radiation on the Martian surface. A groundbreaking discovery unfolded in 2013 when the rover discovered evidence of an ancient streambed, suggesting that liquid water once flowed through the Gale Crater region. The presence of clay minerals, which form in the presence of water, further bolstered the idea that Mars had once had an environment capable of supporting life. Additionally, Curiosity's analysis of the Martian atmosphere, specifically its methane levels, has provided intriguing clues about possible biological or geological processes occurring below the surface. The rover has also reshaped our ability to visualize Mars in ways never before possible. Using its mast cam and other imaging systems, the rover has sent back some of the most iconic images of Mars. The high-resolution images have provided stunning views of Mars's red, rocky terrain, its ancient weather landscape, and even its towering mountains and deep valleys. Curiosity's design was based on a successful Mars exploration rover's spirit and opportunity, but with several enhancements. The rover itself is car-sized, weighing nearly 900 kilograms or 2,000 pounds and standing over 2 m tall. It is equipped with a suite of 10 scientific instruments, including the ChemCam, the Sample Analysis at Mars, SAM, Laboratory, and the Radiation Assessment Detector, RAD. The rover can travel up to 90 m per day on average and has a range of about 20 kilometers. Since its successful landing, Curiosity has exceeded expectations, continuing its exploration long past its initial 2-year mission. In December 2012, the mission was extended indefinitely due to the rover's continued success and its ability to provide invaluable data. Curiosity has been operational on Mars for over 12 years, significantly surpassing its original lifespan. Interestingly, Curiosity was given its name by 12-year-old Claremont from Kansas and is powered by a radioisotope thermoelectric generator, a technology proven by earlier NASA missions like the Viking landers in the 1970s. Unlike solar-powered rovers, the generator enables Curiosity to operate continuously, even during Mars's harsh winters and nighttime when solar power would be unavailable. The heat generated from the decay of plutonium-238 is used to produce electrical power via thermocouples. Now, let's unveil the successor to the Curiosity rover. The story of the Perseverance rover, launched on July 30, 2020, as part of NASA's Mars 2020 mission, the Perseverance rover has been designed to explore Jezero crater on Mars, an area believed to have once harbored water and potentially microbial life. Perseverance is tasked with analyzing the crater's diverse geology, from its sedimentary deposits to the igneous rocks that tell stories of volcanic activity and water interaction. Building on the success of its predecessor, Curiosity, Perseverance incorporates several upgrades designed to enhance its scientific capabilities. While both rovers share similar body plans, landing systems, and power sources, Perseverance boasts new features such as advanced wheels, an improved robotic arm and sampling system, and MOXIE technology, which can extract oxygen from the Martian atmosphere. Since its arrival on Mars in February 2021, Perseverance has made significant scientific strides, revealing surprising details about the planet's geology, history, and potential for past life. Perseverance's instruments have revealed that the rocks at Wildcat Ridge, within Jezero's sedimentary fan deposits, likely formed in an ancient lake environment. These rocks are ideal for preserving signs of ancient microbial life due to their continuous interaction with water after formation. Moreover, the Perseverance rover identified multiple types of igneous rock in Jezero crater, suggesting a complex geological history that includes volcanic activity and interactions with water. This finding contrasts with the previous assumption that all rocks in the crater were sedimentary. The rover's radar imager for Mars's subsurface experiment provided detailed images of Mars's subsurface, revealing solid rock and mafic material beneath the surface. It also confirmed that the crater floor underwent erosion before the deposition of the overlying delta strata, further emphasizing Mars's dynamic geological processes. The rover's sample collection efforts are particularly significant, as the samples will eventually be retrieved by a future mission and brought back to Earth for detailed analysis. As Perseverance continues its exploration, the rover's findings promise to deepen our understanding of Mars and its potential for past life. Its discoveries, along with data provided by other missions, will contribute to humanity's long-term goal of sending astronauts to Mars and establishing a sustainable presence on the Red Planet. The scientific innovations pioneered by Perseverance will shape the future of space exploration for decades to come. The Octavia E. Butler landing photo, taken in February 2021, was captured shortly after the Perseverance rover touched down on Mars, specifically during the landing sequence. The smoke plume from the descent stage is visible, marking the rover's safe arrival. It shows the powerful clouds of dust and debris stirred up by the rover's descent, indicating the intensity of the landing. Moving to the view from the rear right hazard avoidance camera, this photo was captured from a camera positioned at the back right of the rover, providing a clear perspective of the terrain that Perseverance had just landed on. It's fascinating because this camera helps the rover avoid any potential obstacles, offering a safe path as it begins its mission. Another captivating image, taken on Sol 213, shows the parachute and the back shell lying on a ridge about 2 kilometers north of where Perseverance now rests. The image provides a striking view of the site, with the rover's location visible amid the ripples of Eta S, which are intriguing geological features of the Jezero crater. The first color photo taken by Perseverance offers a vibrant and clear image of Mars's surface, showing off its reddish terrain, rocks, and dust. This colorized image gives humanity its first true glance at the alien world surrounding the rover, marking an important milestone in the mission. In a panoramic shot taken on Sol 14, we get a sweeping view after Perseverance's first long drive. The image shows the rover's tracks on the surface, offering a sense of scale and showing just how vast and rugged the Martian landscape is. On Sol 44, there's an image taken of one of Perseverance's wheels, showcasing the rover's own footprint on Mars. Then, there's an image of the landing ellipse and further tracks of the rover, which visually demonstrates the extent of the rover's journey, starting from its landing spot and continuing through the terrain. Next, we get a glimpse of Mars's ancient history with an image of an ancient river system surrounding Jezero crater. It shows how the area once had flowing water, giving us a peek into Mars's past when it may have had water and ancient microbial life.